Hello again, this is Joy Zeigler, and let's get started with the review for the final part 2. The square root property says that you can take the square root of both sides of the equation, and the right side of the equation will be plus or minus its value. So what we need to do is get the variables on the left side and the numbers on the right to start with. So we have 11x squared equals 121. And then we can go ahead and divide both sides by 11. And then we can take the square root of both sides. And when we take the square root of the left side, it becomes plus or minus the square root of 11. So the square root of x squared is x, and that's going to equal plus or minus the square root of 11. Okay, here we have the fifth root of something with numbers and variables. So first of all, we want to look at that negative sign inside of the radical. Since it's a fifth root, it's an odd root. That means that that negative sign can be moved outside of the radical. So from the beginning, we have minus a minus, fifth root of all of that stuff. Now, if it had been the fourth root, or the second root, or the sixth root, an even root, you would have had an imaginary number, and the minus inside of the radical would have been the square root of -1, which would have been I. But for the odd numbers, that makes it a minus sign, and since we already have a minus in front, they cancel each other out. So our final product is going to be positive. Okay, so we are dealing with the fifth root, and we know that 32 is the same thing as 2 to the fifth. And you could say p to the 25th is p to the 5th to the 5th. Q to the 15th is q to the 3rd to the 5th. And r to the 40 is r to the 8th to the 5th. Because the power rule says if you multiply the exponents together, p to the 5 to the 5 is the same thing as p to the 25, and so on. So now we have three things in here that are to the fifth power, so whatever's inside the parentheses can come outside of the radical. Okay, now 2 is also to the fifth power, so we'll go ahead and bring out the 2, and then we'll bring out p to the 5th, q to the 3rd, r to the 8th. And that's our answer. To use the quadratic formula to solve this equation, first we need to get the equation in standard form, ax squared plus bx plus c equals 0. So that means add 8 to both sides. So we have 3s squared minus 7s plus 8 equals 0. And then next we're going to identify a, b, and c. And now we can solve using the quadratic formula. And the quadratic formula, which you're memorizing, is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this problem, x is going to equal negative b is negative 7, plus or minus the square root of negative 7 squared minus 4 times a, which is 3, times c, which is 8, all of that over 2 times 3. So that's going to equal positive 7 plus or minus the square root of 49 minus 4 times 3 is 12, 12 times 8 is 96 over 6. So we continue on. So we get 47 under the radical, and it's a negative over 6. So because there's a negative sign under the radical, that's the same as -1, and the square root of -1 is I. So we have 7 plus or minus the square root of 47I over 6. And you really want to write it in the form of A plus BI. So that's going to equal 7, 6 plus or minus the square root of 47 over 6 times I. Okay, here we have a complex fraction. That means we have fractions in the numerator and fractions in the denominator. And the first thing we need to do is simplify the numerator and the denominator. So let's get common denominators in the numerator. And the common denominator will be xy. So to get that, we multiply 4 over x by y over y and 5 over y by x over x. And that gives us 4y plus 5x, and each of those are over xy. And if we do the same thing in the denominator, we're going to multiply the first term by y over y and the second term by x over x. So we get 6y over xy minus 7x over xy. Okay, so now we have common denominators. We can go ahead and simplify the numerator and the denominator separately. So the numerator is going to be 4y plus 5x, all of that over xy. The denominator is going to be 6y minus 7x, all of that over xy. Okay, now we have a fraction over a fraction, or a fraction divided by a fraction. And when we're dividing fractions, it's the same thing as any kind of division. We can rewrite this horizontally to be 4y plus 5x over xy divided by 6y minus 7x over xy. So once we have it in this horizontal form, we can use the KFC rule, which means keep the first, flip the second, and change from division to multiplication. Okay, so let's do that. We keep the first, so we rewrite 4y plus 5x over xy. Then we flip the second, so we get xy over 6y minus 7x. And we change from division to multiplication. And now we can see if we can cancel anything out. And obviously the xy's can cancel out, and that is all that can cancel. So our final result is 4y plus 5x over 6y minus 7x. Okay, in this problem we are to look at the graph and figure out what the function is when x is 7. In other words, what is g of 7? So if you remember, a function like g of something is the same thing as our normal equation y, where y is the dependent variable and x is the independent variable. And so what does this mean practically? It means we need an equation that says y equals something in terms of x. So we're going to write our slope-intercept equation, which we're going to figure out from this line. Now, b is where it crosses the y-axis, and in this case it crosses at 0, so b is 0. And m is the slope, which is the rise over the run. So you need to take two clear points. We can take 0, 0, and we can take x equals 1, y equals 4. And we can just count up 1, 2, 3, 4, and over 1. So that gives us 4 over 1, or 4. And it's a positive slope because it's going uphill from left to right. So we now know that y equals 4x plus 0, so we can just leave that part off. So y equals 4x. So now to write that as a function, g, we're going to say g of x equals 4x. That's step 2. Once you get your line, you rewrite your y equals 4x as your function g of x equals 4x. Now, now that we've done that, we can go on to step 3 and find out what g of 7 is. And g of 7 is 4, and everywhere we had an x, we're going to put a 7. So g of 7 is simply 28, and that's our final answer. In this problem, we're going to multiply by distributing the square root of 3. So we have square root of 3 times square root of 3 minus square root of 3 times square root of 7. So we know that that's equal to square root of 3 times 3 minus the square root of 3 times 7. So the square root of 3 squared is going to be 3, and the square root of 3 times 7 is the square root of 21. And that's the answer. Here's an absolute value problem, and as I spoke of in class, when you think of absolute value, you want to think of the distance from 0. So let's let this point be 0. And x plus 15 is just some amount, and it's going to be less than or equal to 11 or greater than or equal to negative 11. In other words, the distance from 0 is going to be 11 in both directions. So I've tried to draw this. What we're saying here is that x plus 15 is either going to be less or greater than or equal to negative 11, so it's going to be somewhere in here, or x plus 15 is going to be less than or equal to 11, so it's someplace in here. But in either case, x plus 15, the absolute value, or the distance from 0, is never going to be larger than 11. That's what this inequality tells us. So in order for that to be true, we have to come and write two inequalities, one for the case where x plus 15 is less than or equal to 11, and the other for the case where it's greater than or equal to negative 11. And then we solve for each case. Okay, so if x plus 15 is greater than or equal to negative 11, then when you subtract 15 from both sides, you get that x is greater than or equal to negative 15 minus 11, which is negative 26. And if x plus 15 is less than or equal to 11, you subtract 15 from both sides, and x is less than or equal to 11 minus 15, or negative 4. So the interval that this solution of x is in, now up here we've written what x plus 15 is. X plus 15 is somewhere in this area and this area. But now we're going to talk about what is x after you get rid of that 15. What we found so far is that x is greater than or equal to negative 26 and x is less than or equal to negative 4. So when we plot that, we're going to come over here to negative 26. And since it can be included in the solution set, we use a bracket, not a parentheses. And then we come to negative 4. Well, okay, there it is. And then we shade everything in between. I'm trying to make it thick so you'll see. All of that is included in the solution set. So that's how you graph it, and the way you write the interval is you look at the number line. It starts at negative 26. It's constrained between negative 26 and negative 4, so there are no infinities involved, and it ends at negative 4. And that's the answer. Here's a multiplication problem where we use our formula a plus b squared equals a squared plus 2ab plus b squared. So what we have are 7 plus 9i, all of that squared. That's going to be 7 squared plus 2 times 7 times 9i plus 9i, all of that squared. So that's going to be 49 plus 126i plus 81i squared. But we know that I squared is negative 1. So we get negative 40, or equals 49 plus 126i minus 81. And so 49 minus 81 is 32. So we get 32 plus, and it's negative 32. Negative 32 plus 126i. And that's the solution. This is a three-part inequality. Negative 15 is less than or equal to 3x minus 7, which is less than or equal to negative 4. So you use the same tools to solve for x, but you have to do it to all three parts of the inequality. For instance, you need to get x by itself, so we're going to add 7 to all parts, and we get negative 8 is less than or equal to 3x is less than or equal to 3. And then we're going to divide all parts by 3, and we get negative 8/3 is less than or equal to x, which is less than or equal to 1. So from here we can go to our number line, and we'll call this 0. And negative 8/3 you should rewrite you should rewrite as a mixed number, because then you can say, okay, there's 1, 2, and 1/2 about. So this is negative 2 2/3 right there. And then 1 is simply right here. And since we're talking about less than or equal to, we're going to draw a bracket at negative 2/3, not a parentheses, and we're going to draw the right bracket at 1. So the solution set is everything in between and including those points. And that is what the graph shows. The interval is going to be negative 2 2/3, comma 1, and all of that is enclosed in brackets, and that's the solution. In this problem, we are to write an equation of the line that has the point shown, which is 6 and negative 8, and parallel to the line that's given. And the line that's given isn't yet in slope-intercept form, but it is 3y equals 7x minus 8. Now, what we know is that if the line that we're looking for is parallel, then it's going to have the same slope as this line here. So m is the same for parallel lines. Alright, so our first job is to find out what that slope is. We are going to rewrite that equation in slope-intercept form by dividing everything by 3 to get y by itself, and we get y equals 7/3 x minus 8/3. We don't care about this 8/3, doesn't matter. What matters is the slope, right here, 7/3. So we're going to come up with a new line, y equals mx plus b, with the slope of 7/3. But we don't know what b is. However, we are given a point that goes into our new line. So we are going to use this point slope formula that says y minus y1 equals m times x minus x1. And then we're going to plug in our x1 and our y1 and our m. And then we're going to play around with the equation until it's in the form y equals mx plus b. So the point that we're given is 6 and -8, and our slope is 7/3. We write y minus y1 is -8 equals m, which is 7/3 times x minus 6. Now we have all of the information. We just need to play around with the line until we get y equals mx plus b. Minus a negative is plus a positive, so y plus 8 equals 7/3 x minus 7/3 times 6/1. And let's look at that last term, and you see that 3 goes into both the numerator and the denominator. So we now have y plus 8 equals 7/3 x minus 14. And we're going to subtract 8 from both sides, and we get y equals 7/3 x minus 22. Now we have it in y equals mx plus b format. The slope is the same as we had for our original problem, 7/3. And the y-intercept, -22, is different, which you would expect because it's not the same line. So instead of being 8/3, it is now 22, or -22. And that line that we've just come up with is our answer. That is the end of part 2 of this review, so you can proceed on to part 3.